Hello Year 9 and welcome to exercise 10G. We're going to be talking about how we move parabolas around in the form y equals ax squared. So first of all we have 5 different scenarios. So I'd like you to fill this table in. It's in your notes. So fill in the table for y equals x squared, then do the same for y equals x minus 2 squared, y equals x plus 1 squared, and so on, and see how quickly you can fill that in. So I'll give you a chance to do that right now. I have put the first 2 up now so you can actually check them, but keep doing the remaining questions please. Okay, so I've put all of the answers up for all 5 graphs. Hopefully you got the same answers. You just need to double check them. If there's any errors, it might have been because you didn't put any of the negative numbers in brackets when they were put in place of x. But once you've got your tables filled out, we need to then go and plot them. So you need to put all the points for y equals x squared on first. So you'll put minus 3 comma 9. You'll put a dot. You'll go to minus 2 comma 4. You'll put a dot. You'll go to minus 1 comma 1. Put a dot. And so on for that graph. And then we'll sketch our parabola in. Now that's your basic parabola, y equals x squared. You'll notice when you get to the second parabola that minus 3 comma 25 is a point. And I don't go up as high as 25, so we just won't bother plotting that point. It's too high and it doesn't matter. So we'll start doing minus 2 comma 16. So when you do minus 2 comma 16, and the next one will be minus 1 comma 9, and so on, we plot those points. And what I've actually done, once we plot those points, I'll just get you to make sure you look at the board right now. You notice my last point was 3 comma 1, which is that point just there. Well, I could see the shape of my parabola, and I know the shape of a parabola. If I get to there, I'm just going to continue it up because I know it's in the same shape as the other ones. So just so I get a better picture. You need to continue on and try doing the other ones. I'm color coding them, so you can see I've got red and green and blue and purple and orange. And see how you go when you try to plot them. But you'll notice the green one is, the turning point is 2 units to the right of the red one. So I've written here it's right 2 units when I compare it to the normal graph. So I'll put the points for the third graph on and extend it out. You can still see it's a parabola. In this case, the blue graph is left 1 unit of the original red graph, so I've written left 1 just here, just so I've got a point of reference. I'm going to plot my next one, which is the purple one. It gets pretty hectic with all these graphs all plotted on the same set of axes. So I can see the purple one. If I compare the purple graph to my original normal graph, the purple one is moved, it's the same shape, it's just moved up 3 units. So I'll write up 3 there. Then I'll plot the last one. And when I join it, I'm going to notice that it's, compared to the red graph, it's moved down 2 units. Hopefully you've had enough time to plot those there. And what I would like you to recognize is that the 2 graphs that moved left and right had brackets in the original question. The graphs that moved up and down just had a +3 and a -2 on the end. They didn't have brackets. So brackets are going to control left and right movement. A number after the x squared, adding or subtracting a number after the x squared, will control up and down movement. So here's a bit of a summary of what happens to parabolas that are in the form x squared plus k. Now k just represents a number, so it could be x squared plus 2, or x squared plus 3, or x squared plus 1, or x squared minus 4. K is just a number on the end. When you see that, it controls vertical translation, which is simply up and down movement. Translation means your movement, vertical means the up and down. So, if this number after the x squared is bigger than 0, that's a fancy way of saying if the number after the x squared is positive, the graph goes up k units. So if it said something like this, if it said y equals x squared plus 5, or y equals x squared plus 11, compared to y equals x squared, this graph would be moved up 5 units, and this graph would be moved up 11 units. So that's how those ones work. Let's try our next one. If we look and find that k is less than 0, that's a fancy way of saying if this number after the x squared is negative, then the graph gets moved down. So if I have something like this, y equals x squared minus 3, or y equals x squared minus 5, that's the same as y equals x squared, but it's pushed down 3 units. This graph is the same as y equals x squared, except it's pushed down 5 units. So when it's negative, the graph gets pushed down. When it's positive, the graph gets pushed up. The turning point will always be moved up or down depending on what this value of k is. So the turning point will always be at 0, k, where k is how far up or down the graph moved. It's always going to cross the y-axis at k as well. And the axis of symmetry will always be the vertical line going through x equals 0. So let's have a look at our video. Hopefully we can see that when the graph is moved, has a plus number after the x squared, it's moved up. When the graph has a minus number after the x squared, it's moved below 0. So that's how our graph moves around when it's being moved up and down. It's the same shape, it's just being pushed up or down depending on what number gets put after the x squared. Let's talk about left and right movement. So our left and right movement, the fancy mathematical term for that is horizontal, that's your left and right. Translation, that's your movement. So for left and right movement, there is a bracket. And so if the number in the bracket is, or if the value of h in the bracket is positive, it means we'd have something like this. Y equals x minus, because there's a minus in the bracket there, but if the h value is, say, positive 5, the minus came from the formula. The h is a positive 5. We then put a squared above it. That means that graph is moved right 5 units. You can always check it's moved the opposite direction to the sign that says move right 5 units. So what about this one? That would be moved right 2 units. What about this one? That would be the same as y equals x squared, but right 100 units. If the number is minus, we get something like this. X minus minus 3 squared, and 2 minuses become a plus. So really that's just y equals x plus 3 in bracket squared. If I see that, I look at the plus 3 and I go, this is because of the brackets, it's moved left or right Because of the plus 3, it's moved left 3 when I compare it to y equals x squared. If I had y equals x plus 15 in brackets squared, that would be the same as y equals x squared, but it would be moved left 15. So the brackets control left or right movement. It's a bit trickier because of the plus or the minus. If the graph's moving left or right, the turning point's going to be moved left or right with it. And you can always find the y-intercept by letting x equal 0. And if you let x equal 0, that part would be gone. So the turning point is minus h squared. So let's continue. The axis of symmetry will always be through the turning point. So it's at x equals h. And we can hopefully see by this graph, when I have a minus sign in the bracket, it's moving right that far. When I have minus a minus, which is really just x plus that number squared, it's moved left that far. So we need to make sure we understand how the left and right movement happens. Now let's do a summary of all of this. We can actually move things right side up or upside down. We can move left or right, and we can move up or down. This one, A out the front, also controls how fat or thin it is, as we discussed the other day. But if the number in front of the bracket is a positive number, it's concave up. In other words, it opens upwards. If the number in front of the bracket is a negative number, it's concave down, which means the parabola opens downwards. If inside the bracket you've got a minus followed by a number, we know that it's going to move the whole thing right. If there in the bracket is something like a plus followed by a number, that means the whole thing is moved left 3 units. It's always moved the opposite direction to the plus or minus in the bracket. If there's a number on the end, it's going to move it up or down. The turning point will always be at h, because that controlled the left or right movement, k, because that controlled the up or down movement, so the turning point would be at h, k, and we'll do some examples in a little bit. So let's just see a little bit of this in action on the video. If there's a minus in front of the bracket, it turns it upside down. If it's a positive, it makes it open upwards. So that's just the effect of the minus. We could change that 1 to a different number, and that would make it fatter or thinner. We can look at our brackets now. The brackets control left and right movement. So if I get 2 minuses, that's the same as a plus, and when there's a 2 minuses there, it's the same as a plus, which moves it in the negative direction. It's always the opposite to what's there, which is a bit strange. We can then look at the number on the end. If it's positive, it moves it up that far. If it's negative, it moves the graph down that far. And then we can start doing all of this together. Like we can have number at the front, number in the bracket, and a number on the end, which is going to move things around again. So notice I've got number in the bracket, move right 2 and up 1. Now it's upside down, right 2 and up 1. So we can start changing these numbers around. And that moves the parabola all over the place. Let's try doing some sketches. Here's our first one. Y equals x squared plus 2. So I know the plus 2, because it's not in brackets, controls up and down movement. So it's just moved up 2. It's the same as y equals x squared, but it's pushed up 2. And I've been asked to show the turning point and the y-intercept. So I'm going to write them down. The turning point and the y-intercept. Well, the turning point's at 0, 2, and the y-intercept is at y equals 2. Let's try part B. With this one, we know the graph is going to be moved down 1 unit because of the minus 1 on the end. Because there's a minus in front of the x squared, it makes it upside down. So this is the same as y equals x squared, except it's upside down and down 1 unit. So it's upside down because of the minus in front of the x squared, and it's moved down 1 because of the minus 1 on the end. So if I was to go down 1, I'd be at minus 1 on the y-axis, and opens upside down. That's the basic shape of my parabola. It's just a sketch. It's a freehand sketch. It's just the basic shape, but you must show that minus 1. And I also need to write down what the turning point and y-intercept are. So where is the turning point? What is that spot there as a point? Well, it's the point 0, minus 1. And where does this graph touch the y-axis? The y-intercept touches the y-axis at minus 1. So I can write y equals minus 1 as a normal way to write it. You could write it at 0, minus 1, but normally we write the y-intercept is at y equals minus 1. Now, with part C, we've got brackets, and we know brackets control left and right movement. Now, because this bracket has a minus 4, it doesn't go in the minus direction, it goes right 4. It's the same as y equals x squared, but it's pushed right 4 places. So that we go right from 0, 0, we move right 4 places, and we put a dot, and we do our parabola opening upwards. I know it opens upwards because there's no minus in front of the bracket. There's my parabola. But I also need to show the turning point and the y-intercept. Well, the turning point I can see here. Turning point is across 4, up or down 0. So it's at 4, 0. The y-intercept is there. Now, how do you find a y-intercept? The trick to find any y-intercept is to ignore x. Just imagine there was no x there. So it's negative 4 squared. What's negative 4 squared? It's 16. So the y-intercept is at 16, or y equals 16 is what we'd be better off writing there. Now our next part has left or right movement because of the bracket, but it's upside down because of the minus in front of the bracket. So compared to y equals x squared, this is upside down, and it's moved left 2. Because it's a plus, we move it left 2. So I'm going to put a dot on the x-axis. Left 2, it's just a guess, it's a sketch. I don't have to count out each of the, I'd have to go minus 1, minus 2, minus 3, minus 4. I'm just going roughly where I think minus 2 might be. It's upside down. Basic parabola shape. So where is the turning point? Well, the turning point's here at minus 2, 0, because I went left 2, up 0. Where's the y-intercept? Remember, to find the y-intercept, we imagine there's no x part. So look inside the bracket. What's plus 2 when you square it? Plus 2 when you square it gives 4. And then we've got that minus out the front, which means that the y-intercept is at minus 4. So we can write minus 4 there. Now you don't have to write this part down if you actually label it correctly on the graph. I'm not as worried about that as long as these numbers are labelled. Now let's have a look at part E. This is trickier again because there's brackets, which means it's left or right movement happening. There's a plus 1, which means there's also up or down movement happening. So when we compare it to our basic y equals x squared, this graph is moved right 3 and up 1. So because of that minus 3, it's moved right 3 because that's inside the brackets. And because of that plus 1, it's moved up 1. So then when I go to do my sketch, I look at the point 0, 0, and I'm going to go right 3 and up 1, and I'll put a dot. So there's my dot for right 3 and up 1, and that's my turning point at 3, 1. Where does it touch the y-axis, the y-intercept? Well, the y-intercept is here. How do you find a y-intercept? You pretend that x doesn't exist. So look inside the bracket. It's a minus 3 now. What's minus 3 when it's squared? Minus 3 squared gives 9. And then we add that 1 to it, which gives 10. So we get 10 as our y-intercept. So we could just write y equals 10. Don't worry about that part there. You can if you want, but it's not essential. What's happening with graph F? Let's see if you can picture what it might be. Have a go at it first. I'll just pause for a little bit for you to have a go. Okay, let's see what you got. Well, there's three things that are happening here. That minus means the graph will be upside down. Because there's brackets, we've got left or right movement. Because there's a +1 in the bracket always goes the opposite direction for some reason. It's -1, so it's left 1 unit. And this -2 on the end means the graph is pushed down 2 units. So normally you'd start at 0, 0, but this one's moved left 1 and down 2. So start at 0, 0, left 1 and down 2. So left 1 and down 2, and then you draw an upside down parabola. So that's my point there, left 1, down 2. So when I look at this graph, the turning point is left 1, down 2, so that's -1, 2. Where is the y-intercept here? How do you find a y-intercept? Pretend the x doesn't exist. So look inside the bracket, because BODMAS says do brackets first. Inside the bracket it's a +1, and when that's squared, you get 1. There's a minus in front of it, which means it's now a -1, and then you take away 2. -1 take away 2 is -3. And now you could do that all on your calculator, just putting in x as 0. So your y-intercept is at -3. Y is -3. Here's some bonus questions that aren't on your booklet, but I want you to look at. It says find the turning point. Now the turning point is normally at 0, 0. So this parabola was pushed up 7, so its turning point will be at 0, 7. It's just moved up. So when you look at the turning point, remember the first number of the turning point comes from left-right movement. The last number comes from up-down movement. So let's have a look at our next one. Is it moved left or right? No, because there's no brackets. Is it moved up or down? It's moved down 4. So the turning point will be 0, -4. What do you think the turning point for this one would be? Is there left or right movement? No. It's upside down, but it's pushed up 2. Because there's no left or right movement, it'll start with a 0 and it's pushed up 2. Turning point will be 0, 2. What about this one? Upside down, no left or right movement because there's no brackets, and down 9. So it'll be 0, -9. What about this one? Hang on, brackets, that's left or right movement. So this was moved right 8, and it doesn't go up or down. So the turning point will be 8, 0. There's right 8, and it didn't go up or down. This one, moved left or right? It's moved left 2.5. So the turning point will be left 2.5, up or down nowhere. This one has left and right movement and up and down movement. So it's left or right, so it's moved right 5, up 2. So the turning point will be at 5, 2. For this one, left and right movement, it's moved left 4, down 1. So the turning point will be left 4, down 1, -4, -1. So hopefully you get an idea of how to find the turning point when you see parabolas written. Here's one more, trickier one. It's upside down because of the minus out the front. It's moved left 11 because of the bracket, up 23. So the turning point is left 11, up 23, -11, 23. So it's time for you to try doing some questions. Enjoy. You have the rest of this lesson and next lesson to finish this off. Bye for now.